So, guys, since this is our first session, we'll be going through the computers and software. How are they changing everything, and what's the condition of computer science in our society at present at the moment? So, as you all know, computers and softwares are changing everything. Now, let's talk about getting computer science into our schools. But let's start by talking about dreams, opportunities for you, and opportunities for your community, and most importantly, an opportunity to create something. The beauty of computer science is that imagination and creation lie at the heart of the field. Your smartphone or the laptop which is driving this presentation are innovation platforms. They allow dreamers, idealists, entrepreneurs anywhere in world to bring their ideas into reality if they know how to write the software that drives our modern world. But what we notice is that the majority of schools don't teach computer science. As you're seeing in the slide, 90% of parents want their child to study computer science. But 45% of high schools teach computer science, just half of it. So, 9 out of 10 parents surveyed want their child to learn computer science. But according to our Access report, just 45% of high schools teach computer science courses. Our education system clearly needs to evolve to bring computer science to students that want to learn this subject. And this evolution isn't something the tech industry wants. It is clearly something that parents and students want who needs creativity. Creativity, coding. Coding and creativity are one and the same, you can say. So even when students enjoy computer science and arts the most, our syllabus, our what so called the education system has still not evolved until then. You can see Darwin's principle about survival of the fittest. If you are a PCMB student, you will know the fittest will survive. But here, since even then computer science and arts are leading, even then the education system is still not evolved. So you are seeing the graph here, art and design goes higher, then performing arts, then comes computer science and engineering, and then comes the rest. 54% of students enjoy computer science the most. So next coming, yeah, some may think our students should learn to code. Let's address a few misconceptions and themes we consistently hear from our advocacy for students across the country. The first is that we should be teaching our kids to code. So, even then, you are all not kids, but this is an important part of coding. You should understand what's the situation of coding in our world right now and in our education system. So, our view is that schools should be teaching computer science. Coding is an important tool for computer science, but it is a bit like arithmetic is a tool for doing mathematics and words are a tool for English. Coding creates software, but computer science is a broad field encompassing deep concepts that go well beyond coding. Computer science is just not coding as you think. Computer science is well beyond that. It includes hardware, it includes ENC, everything. And all students should have access to computer science courses in their schools to build their creativity, to build their logical reasoning, and whatnot. And let's go to the next slide. Yeah, some may think computer science is just about learning technology. When people hear the term computer science, they often think this. What they don't realize is that the beauty of computer science lies in the process to create the technology. See, if you use Facebook, it's just like you are using a Facebook. Someone has made it. For example, Mark Zuckerberg has made it, but you are using Facebook. But how do you feel when you are by your own have created Facebook and using that and seeing everyone use your Facebook? It seems special, right? So that's the misconception everyone have. They just think that computer science is just about learning technology, but the importance of computer science is it's it's the process to create that technology. So I want you to understand that. So here another slide I have put. The reality is that computer science is about logic, problem solving, and creativity. It teaches students how to think differently about problems they are trying to solve in any context. It teaches kids how to create digital artifacts and how those artifacts impact the world around them by looking at issues such as privacy and security. A very simple way to think about this is CS teaches kids how to create new technologies instead of just being consumers of technology. What I said now about Facebook, yeah, if you just use Google, how it feels. I am using Google, someone has made it for me, I'm just using for free. But if you create another your own search engine, for example India search engine, if you use India search engine, how it feels, you are the creator of India search engine, and how it feels when your friends and family are using India search engine. It feels special, yes. I have experienced it by myself. So just as important as recognizing what computer science is, recognizing what it is not is also important. It is not basic HTML design. HTML means hypertext markup language. We'll be seeing later in our further sessions. So it's not basic HTML design. It is not learning to use applications or a Photoshop course. Means Adobe Photoshop, which will be used to edit your photos. That learning Adobe Photoshop is not creativity. It's just learning what already has been created. But if you can create something which can build 3D photos, just think, just put in your creativity into that. So many of these things can be part of a computer science course, but they are not the foundation of the curriculum. We can do better than simple technology literacy. We can make kids creators of technology. You too can become the creator of technology. Creator of technology in computer science just means coding. Yes, your coding with your logic, problem solving abilities, and your creativity, your coding will be the strongest. And if you start coding from now, then you will be job ready also, and your creativity will be increased, which is the most important in the upcoming decades. For example, consider the fact that the first computer was built in 1943. Okay, the first computer was built in 1943, but the first computer program was written in 1843 by Ada Lovelace. Quite a genius woman. Yeah, you can just imagine 100 years before the computer program is written. Means computer science just is not about using the present technology. It's just creating. Writing a computer program is about using logic to creatively solve a problem. For example, a problem means you have to process a mark sheet of your school. So if you start processing, if you should do the same work for 6th class, 7th class, 8th class, 9th class, every grade you must do the same. So if you create a program which does the same thing for you, if you do for one, it will be enough for the 12. The computer program will do the rest. That's just creativity to solve a problem. How you put in your creativity and logical understanding, reasoning will do all works. Not just about the technology that carries out the program, your creativity. See guys, I'm stressing creativity so you can think what's the link between creativity and coding. They are one and same, like that we can say. Some may also think computer science is vocational, it's just to get a job. We hear a lot about the number of computing jobs in the US economy. That learning computer science is just about getting a great job, but it's not just like that. Computer science is foundational. If you have computer science foundation in you, if you have built your foundation with bricks using computer science too, then your building will be the strongest. May it be electronics, may it be anything. But technology, see, in the next slide I'll be showing technology affects every field. The reality is that technology affects every field of commerce. I'm saying again, stressing again. In healthcare, computing is part of operating rooms, operating theaters every day, and is enabling breakthroughs like these contact lenses. You're seeing here contact lenses that detect levels of insulin for people with diabetes. In space, we are depending on a generation of robots to explore where humans cannot go. In our homes, we are automating everyday things like our heating systems. Yeah. On our roads, we depend on navigation systems to get us home, and now we are experimenting with bringing self driving cars, Tesla and Google cars, into our everyday lives. In entertainment, blockbuster movies depend on computer science to bring new characters to life. See, this is the animation, graphic designing who are going. So, and every single field, this trend is growing across every single industry. I'm saying it again. So, let's take a little audience pop quiz. How many of you can answer these questions? What is photosynthesis? Even a child will answer. Or what is H2O? Even a fifth class student can answer. These are all things that we expect kids to graduate high school knowing. Every 21st century student should also have a chance to learn about algorithms, how to make an app, or how the internet works, how are websites created. And right now, there is no expectation in our school that students will even have a basic understanding of these concepts, even though they are driving a large part of our society. It is equally important that students understand what a for loop is and how it is used and how to design algorithms as it is that they understand how to solve an equation or how plants live. The main reason that computer science is now foundational knowledge necessary in every school is because it will allow students to think about problems differently. Students will gain computational thinking skills which embody a more robust way to think about problems. And the problem solving process can be applied to any field of study and to any problem. If you are facing a big, ambiguous project at home or at work, computational thinking and problem solving processes can help you break this problem into smaller chunks. Recognizing what's important and what needs to be solved first are critical thinking skills that are valuable in any context. See, just like they learn about photosynthesis, the digestive system, or electricity, coding is important and they must know the basics of coding. So, some may think there's a temptation to think that this is only about the IT industry, that only Google, Microsoft, Facebook, Twitter are participating in this new opportunity. But in fact, computer programmers are needed in every industry and across the country. So, what will a career look like in 2030? It will be a workforce that is very data driven, that leverages technology to bring new ideas into the marketplace. Employers will need workers that understand not only how to use technology, but how to create and manipulate it. Just being facile with technology will not be enough. Simply put, our students will need to be innovators and creators. Students must build in their innovation and creation. What they make is what will be valued in 2030. And to do this, they need opportunities to learn computer science. That doesn't mean just a computer science degree, but the skill of computer science. And also, if you notice, 83% of parents and 64% of principals in rural and small towns believe offering computer science is more or equally as important as any required course. Yeah, computer science, since it's used in each and every field you notice day by day, even then, why is coding still not put in like a root in our education system? It must become the strongest root ever, since this will be important in the future coming decades. If you also see the value of computer science education, a computer science major can earn 40% more than the college average. So you are seeing lifetime earnings of a high school graduate comes out to be $0.58 million dollars, and lifetime earnings of a college graduate $1.19 million dollars. Lifetime earnings of a computer science major who has graduated in computer science will earn a dollar 1.67 million. This source is Brookings Surveys. So here you can notice what's the value of computer science education. It's also increasing your job job offers, everything. So computing jobs are the number one source of new wages in the United States. So you can see here 16.3% computing. So 500,000 current openings. These jobs are in every industry and every state, and they are projected to grow at twice the rate of all other jobs. So, yeah, you are looking here at the graph, you can see computing is the most 16.3%, you cannot find in management too. So, this will be also doubling every year. So, just look at it. And some may think this problem is about STEM. STEM means you will know science, technology, engineering, and math. Everywhere from the president of the US to local school boards have identified STEM education as a major issue in facing the US. But why it's not done in India? India is just depending upon the historic period of education system. Why still in 2020, I mean in this year, they have released a new curriculum with coding added to it. So how far it will be implemented is to be seen. And also, I am remembering about some saying from Japan, I think. Indians are good at planning, but not at executing. Yes, that goes. See, now let's don't move on to another topic. Let's come back. Yeah, what I would suggest is that we have a major computer science problem when it comes the alignment between access to CS science education and opportunities in our modern economy. This chart shows the projected STEM jobs in our US economy broken out by computing jobs and all other STEM jobs. And this chart shows students graduating with STEM degrees broken out by CS versus all other math science. See, you are seeing this graph here. 67% of all new jobs in STEM are in computing, and 10% of STEM graduates are in computer science. So, you can notice how computer science is important in each and every field. So, now let's move on to the next slide. See, yeah, this is not important here. And our state policies can also help this fix this picture. So often the reason that students don't take computer science is that they don't have access to it. We need to think differently about diversity problem in tech, and that needs to start with exposing all students early on to computer science by starting in the formal education space. If you are giving them the right what you say the right basics, the foundation with bricks of coding, then they will be creative and they will be the right choice in the future. And in schools that teach CS2, enrollment is through the roof. You can also see here. And this slide is not so important. Coming back to the last slide, what I have to say here is education today has numerous controversial topics, but computer science isn't one of them. At a time that we are fighting about what should or shouldn't be taught in our schools, 90% of parents are asking for computer science in their schools, as you can see in this pie chart from Access report. We have momentum, we have grassroots support. What we need now is schools to put two things into place. First, high quality rigorous curriculum and courses. Second, we need to prepare teachers to teach our students. We need states to launch initiatives build on these two goals and focused on improving access to CS education. So guys, in this video I have cleared you all the what's so called what's the condition of computer science in our present world, and this is the basic for coding. Since you know the present condition in our world, you can think about the further ways to learn coding and you will be motivated, I hope so. So this session would have been a knowledgeable session to you. So I think I am very confident that you have gained maximum knowledge from this. So now the what's introduction of coding will be from the next session. So don't miss the next session. And thank you for watching this session. You can also share this with your friends too, and the link will be sent in Google Classroom. Okay, thank you guys. Let's stop this video.